Hello viewers, in today's class we are going to discuss a very important problem from integral inequalities using the concept of mean value theorem for integrals, right? So here we are given this problem in which we have this integral I that is from 0 to 2 pi dx over 10 plus 3 times cosine of x, and then we have to show that this integral I it lies between 2 pi by 13 and 2 pi by 7, right? So we have to prove this inequality for this integral I, right? And moreover here we can prove this inequality by another method also, but here we'll make use of the concept of mean value theorem for integrals, right? So let us first see the general statement of mean value theorem and then see how we can apply mean value theorem to this integral I to get this inequality. So viewers, the mean value theorem for integrals states that if we have a function f of x which is continuous function in the interval a comma b, then there must exist a number say alpha which lies between a and b such that the value of the integral that is from a to b f of x dx is equal to b minus a times f of alpha, right? So this is the statement of mean value theorem for integrals. So here what we have a function f of x which is a continuous function in this interval, right? And then we must have some number say alpha, or we can denote this number by some other alphabet also. So we can also write c here. So there must exist some number alpha between a and b such that the value of the integral of this f of x from a to b is b minus a, that is the difference of the upper limit and the lower limit, times the value of the function f of x at this point, that is x is equal to alpha. So we'll make use of this result to arrive at this inequality. So now let us first compare this integral, that is 0 to 2 pi dx over 10 plus 3 times cosine x with this integral, that is a to b f of x dx, right? So a is 0, the lower limit, b is upper limit, that is 2 pi, and f of x is equal to 1 over 10 plus 3 times cos of x. So now according to this statement, we can now write the integral that is 0 to 2 pi fx is 1 over 10 plus 3 times cos x, and here we have dx is equal to b minus a. So b is 2 pi and a is 0, so 2 pi minus 0 times f of alpha, right? So f of alpha can be obtained by replacing x is equal to alpha in this f of x. So we have 1 over 10 plus 3 times cos of alpha. So now we have 2 pi minus 0 is simply 2 pi, and here we have 10 plus 3 times cos of alpha, right? And this integral is our integral I, right? So now we have I is equal to 2 pi over 10 plus 3 times cos of alpha, where this alpha it lies between 0 and 2 pi, right? And now we'll make use of some trigonometry to start with this expression, and then we'll arrive at this inequality. So viewers, from trigonometry we know that the value of cos alpha that is this term, it lies between -1 and 1. So our starting inequality would be this, that is cos alpha is lying between -1 and 1. So the maximum value of cosine alpha is 1 and the minimum is -1. So let us multiply this inequality throughout by 3. So we have -3, here we have 3 cos alpha, then we have 3 ones are 3, because we have to get this term, that is 3 cos alpha. Now let us add 10 throughout this inequality. So we have -3 plus 10, here we have 10 plus 3 cos alpha, and here we have 3 plus 10. So this is 10 minus 3, 7. This is 10 plus 3 cos alpha, and here we have 13. So now let us divide throughout this inequality by 2 pi, right? Because 2 pi is a positive number, so there is no harm in dividing throughout by 2 pi. So we have 7 over 2 pi, and here we have 10 plus 3 cos alpha divided by 2 pi, and that is less than or equal to 13 over 2 pi, right? Now let us take the reciprocal of all these three terms. So when we take the reciprocal, we have 2 pi by 7, and then we have the direction of the inequality get reversed, and we have 2 pi 10 plus 3 cos alpha, and then we have here 2 pi over 13, right? So now replacing 2 pi over 10 plus 3 cos alpha by this integral I, we have 2 pi over 7 greater than or equal to I greater than or equal to 2 pi over 13, right? So we can also rewrite this inequality as 2 pi by 13, that is less than or equal to I, that is less than or equal to 2 pi by 7. So this is our required inequality. So viewers, this is how, by making use of the concept of mean value theorem for integrals and using some trigonometry and using some concepts from inequalities, we can prove these kind of inequalities.